Hi everyone, it's Shannon from Miovision here. Thanks for joining today. Sal, did you want to introduce yourself?
Yeah, thanks so much for having me, Shannon. Hey, everyone. It's great to be on another Miovision webinar. I hope all of you, or most of you, tuned into the safety analytics webinar last month. But here at Miovision, I'm on the product marketing team, specifically overseeing our safety analytics, our insights solutions, things like traffic management, really a lot of the work that we do on the ITS line of business. I work closely in tandem with Shannon, as well as our product management team to ensure that the voice of the market is heard by our product and engineering team so that we can continue to build products that you find value in.
And I'm Shannon Hebert. You may have joined me on another one of our webinars over the past couple of years. I'm the ITS marketing manager, and I work with our internal teams and partners to create programs like this webinar in order to share information about our Traffic Link platform with all of you. So I thought we'd start out talking a little bit about us, and more specifically Traffic Link. We do like to consider ourselves the smartphone of the intersection. Just as you have your mobile phone, a single device that gives you access to so much information and so many apps like your email client, your photos, calendar, Spotify for your music and podcasts, we like to think of ourselves as the same thing, but for the intersection. We have a set of hardware that is installed, and on top of that, you have several software applications that you can use or unlock as needed. So why don't we take a look at our Traffic Link hardware, just as a reminder or an introduction for those of you that don't know. But this is our smartphone of the intersection, or our Traffic Link hardware. It might not be as sexy as your iPhone, but we think it's pretty powerful. So first, on the left of the screen, you see a Smart Link. This is a piece that provides connectivity and remote access to your cabinet. Then we have our Smart Sense unit. It's what's doing the computing at the side of the road. This allows us to do all of our real-time analysis based on computer vision for detection, traffic counts that we're talking about today, and alerts. And then you have our SmartView 360. This is our fisheye camera that has a view of the intersection. It not only provides remote monitoring so that you can see what's happening at the intersection, but it also feeds video into the Smart Sense to create data based off of what the camera is actually seeing. Once you have the Traffic Link hardware installed at the intersection, all of our solutions are simply software applications you can add as you need them. Today we're talking about continuous counts, but if you want information on any of our other applications, be sure to reach out to us afterwards or check out our website. So what is continuous counts? It provides data that is continuous, reliable, and accurate so that traffic engineering and planning teams can make data-driven decisions that improve the mobility and safety for all citizens. So why is this important? Cities are bustling with cars, pedestrians, cyclists, e-scooters, trucks, and they're all vying for space. It's important to understand how people are moving through the city and the impact all these modes have on the traffic network. I recently read a stat that said 60% of the world's population will live in urban areas by 2030. That's a lot of people in defined areas, and with that comes a significant increase in congestion and pollution. As this growth occurs, do you have the tools and resources in place to help you understand how to move your citizens through your city safely and efficiently? We believe with continuous counts, it can help you do so. One, because it's multimodal by default. As I mentioned, cities are no longer car-centric. Roads are shared by pedestrians, cyclists, buses, and trucks. All are equally important and need to be measured. These counts are vital to helping engineering, operations, and planning teams like yourselves in making data-driven decisions that improve everyone's mobility and safety. Secondly, continuous counts allows for permanent traffic studies. You will always have accurate, real-time, continuous data at your fingertips when you need it. It also allows for granular data and advanced study types. Since we can capture several different types of classification, as well as the direction or movement, This data can be used for both high-level planning and detailed engineering projects, such as signal retiming studies, ATRs, or urban planning projects. And finally, it's securely hosted historical data. The data is always accessible. At any point, you can go back and take a look or draw comparisons on what's happening in your network today versus in the past in order to make confident, data-driven decisions about your network.
Awesome. Thanks so much, Shannon. Now, I know the focus of today's webinar is all about continuous counts, but I had to throw in a slide on Miovision Scout. I think many of you are familiar with this product, given that 34% are using video for data collection means. Many of you may very well be Miovision Scout customers, but really this product is our portable traffic data collection. It straps to a utility pole in the field. It has a telescopic field of view, and it can last up to 72 hours in the field. This product has a very special place in our hearts. I don't know how many of you are familiar with this, but Miovision Scout was really the product that led to the birth of Miovision as a company. It was over a decade ago now, where Curtis, our CEO, was a University of Waterloo student on a co-op term, and he was positioned at the intersection manually counting vehicles, and he just thought to himself, holy smokes, there's got to be a better way to do this. And that was the idea that led to the birth of Miovision Scout. And here we are, 12 years later, we've been working with the industry, with many of you and our customers, on several projects around signal retiming studies, TIAs, even decisions around urban planning, to provide you with traffic data at the highest standard with a high amount of accuracy with quick turnaround rates. This product really is the gold standard when it comes to traffic data collection in the industry. We're extremely proud of it. And while the product does exist today, the focus of today's webinar, as Shannon had mentioned, is all about how can we take the technology of Miovision Scout and apply it at the intersection permanently so that you can get 24/7, 365 multimodal counts. This is where some of the fun really begins, because in a second here, what I'm going to do is I'm going to play this video for you. Okay, so do what you've got to do to warm up, flex those eyes, get some eye drops, get some glucose in your system, prime yourself. But I'm going to play this video for about, let's say, 10 seconds. And your job is to count the number of vehicles, the number of pedestrians, the number of cyclists in the frame, and make note of their directionality. Okay, so we're going to go in 3, 2, 1, count. All right, let's stop it there. Feel free to message us in the chat window with the number that you counted. But the purpose of this slide is that when we think about data collection, the ability to collect traffic data in urban environments like this, it's extremely, extremely difficult. Okay, even if you were to use some other means of collecting your data or another type of technology, whether it's road tubes or radar or even manual counts, in this case, which happens to be downtown Toronto, those technologies just completely and utterly fail, because there's no way that they're going to be able to keep up with this density of volume that we're seeing. And the only way that you're going to be able to get this type of data is through a solution that leverages video and machine learning. It's that combination that creates this really powerful product that's scalable enough to deal with this level of density, but also the different variables at play. And for context, these intersections in Toronto will see anywhere from, say, 70 to 80,000 pedestrians, about 30,000 vehicles, and about 1,000 cyclists over a 24-hour window at an intersection. Of course, that's in a pre-COVID-19 era, but it's just incredibly powerful to see how at the edge, in real time, the computer vision is able to accomplish something that a human person would not even be able to accomplish. Now, the application of computer vision to traffic data collection is really exciting, and I often joke with our computer vision architects as well as our software developers here at Miovision that they must be fantastic parents, because the principles of parenthood really have some strong carryover when it comes to teaching a computer how to see. Now, I myself have not reached that milestone in life, but Shannon, I know you have, and I'm sure many of you in the audience will be able to relate to this example. But if we think about how learning occurs in our infants, it starts off with a lot of rhetorical pedagogy. They'll ask questions like, "Hey, what's that? What's that? What's that?" They'll be looking at a car, and those are the types of questions that they'll be asking. And it's our job as, being more senior to them to educate them and say, "Oh, what you're seeing is a car, that's a car, that's a car." And so with enough time and enough training, they start to recognize different attributes that make up a car, so that when they see, another car, let's say that they've seen 1,000 cars to this point, and this red Nissan happens to be vehicle number 1001, even though it's slightly different from this white car on the left, they'll look at it and think, "Hey, this has a lot of similar attributes as the previous cars that I've seen. It must be another car." And that same type of model applies when you present them with, say, a concept car, which has slightly different characteristics, but the attributes are still the same. That's the premise of using something like neural networks and computer vision. And the key difference here is that we're not fully looking at objects. What we're looking at are attributes of an object. So we can see we're identifying, say, these are the wheels, this is the height of the vehicle, this is the length of the vehicle, this is the windshield. We're essentially training it to recognize these different attributes so that it can build up its model, build up its schema, and carry that over into future objects that it sees. Whether we all realize this or not, every single one of us intuitively does this. We could present you with any type of object that's slightly different from a preceding model. The example that I give is, back in the day, the Motorola Razr was the hot phone, and Shannon, I think you spent some time at Motorola, so this is likely striking a note with you. But if we were to present a Motorola Razr and put it side by side with, say, a BlackBerry Bold 9900, of course, we're a Kitchener-Waterloo company also, so we've got to give credit to that company, and then also put it side by side with a Google Pixel. Though the form factor is slightly different, the attributes of those phones are similar enough for you to deduce that, hey, you're also looking at another type of phone. So the picture that you're seeing on the screen here is quite literally an example of how we're pumping training data into our computer vision model. You can think of it, to continue on with these parenting analogies, this would be us spoon feeding our child knowledge, if you will. So it's a picture of the cityscape here. You can see that we have a whole host of cars that we've labeled, even different types of vehicles. We've got a work van, a single unit truck, and then along the sidewalks, we've actually identified pedestrians. So we're continuously feeding data into this computer vision model. So that's getting better and better day by day. With enough training data, what you end up with is this traffic artificial intelligence. And it's not a far stretch to say what you're seeing on the screen here is the brain of our child. There's some really weird, quirky analogies going on with parenting and computer vision. But what you're seeing on the screen here is what's called a cluster analysis. It's visualizing how like attributes end up bucketed together. So you can see on this legend here are the classifications within our schema, and they're all rendered on this cluster analysis. I think it's a really cool spot when you start to see some overlap. So in this big body over here, these are all cars, and this red blotch over here is pickup trucks. This little bridge is where the model is starting to have a little bit of a hard time discriminating between a car and a pickup truck. And the example that my director often gives me is this is where an El Camino would potentially sit. I don't even know what an El Camino is. I had to look it up on Google, and I can see why our model might see that being an object that would fit into this middle category. What all of this translates to in the real world is a product for our customers that not only provides continuous counts, but can also serve as a tool that does detection and actuation and is future-proof for further applications around things like safety analytics, as well as adaptive traffic signal control. Now, rather than staying on the slide deck, what I think I'll do is actually pull up the traffic link portal, because seeing this in action usually makes it that much more exciting. So just give me a second to get that set up. And perfect. All right, so for those of you who are familiar with the Traffic Link platform, you'll recognize this landing page. But for those of you who are new, this is the Traffic Link platform. It's the web application that we have that feeds up all of our software value. Once you have that hardware deployed, a lot of functionality can be unlocked through this Traffic Link platform. Right off the kicker, what you're welcomed with is this network-wide view into your deployments of your Miovision technology. Anywhere you see this little green dot, that means that there's a Miovision Smart Link present. And anywhere you see a green dot with a little camera icon, it means that there's also a Miovision SmartView 360 present. This particular example, you can see that there's some active alerts taking place. This is an example of our signal maintenance package. It's something that our traffic operations teams, signal technicians, traffic management, maintenance teams absolutely adore, because it's proactively surfacing maintenance issues to them so that they can break out of that vicious cycle of being victim to citizen complaints. Of course, today's focus is all about our continuous counts product. So let's jump into this particular intersection over here. Let's load up the video. Now what you'll see is this particular intersection is actually equipped with 2 of our Miovision SmartView 360s. Depending on the intersection, there may be a need for 2, depending on the complexity as well as the size. But in most of our cases, most of our deployments are, in good position or in good shape with just the one Miovision SmartView 360. This video feed is streaming over our LTE connectivity, so every SmartLink device is a communications tool that has wireless capabilities built into it, and we're streaming this over 4G LTE connectivity. What you're seeing here is our detection overlay screen. This particular intersection is equipped for a whole host of functionality, so it's not only being used for continuous counts, but also detection and actuation purposes. You'll notice that there's these yellow detection zones drawn all over the intersection. You've got your yellow detection zones for your pedestrian crosswalks. And then if you look to this top left image over here, you've got detection zones drawn at the stop bars you normally would with detection systems. I do want to call your attention to this bottom left square over here, because you'll notice in the far corner right here, hopefully you can see my cursor, we have some detection zones drawn in over these tracks. Now, this particular intersection also has a light rail transportation system in it, which is why it's such a complex intersection, and we actually have our dual camera configuration. You'll notice as soon as a vehicle or a pedestrian enters these detection zones, the computer vision in real time is classifying the vehicle, the pedestrian, or the cyclist. And if we go to this middle top square over here, that's our turning movement counter, our TMC overlay view. As soon as a vehicle goes through one of these purple lines, which represents their trajectory through the intersection, you'll notice that these purple lines pulse. Hopefully we can get some movement. All right, there we go. You'll notice that these are going to start to pulse. That pulse indicates that the vehicle or the pedestrian or the cyclist has been counted. So we know the classification and we also have the count. This is a really important piece to highlight because what we're doing is we know where and when the vehicle enters the intersection. We're actually following it all the way through, and we know where and when that vehicle exits the intersection. I call that out because there's an incredible amount of accuracy that comes with that. There's absolutely no guesswork on our end. We're providing a highly accurate source of data collection. A lot of other players in the industry, they don't do this. What they'll do is they'll look at, say, something like queue length, or they'll make a time-bound guess based off of, we saw that the vehicle entered at this point, it exited the intersection at this point. They'll have some variables, they'll make a time-bound guess, and they're trying to fill in the gaps with the best data that they have. We don't do that. We actually follow vehicles as well as pedestrians throughout their entire trajectory before we count and label them. Now, the way that all of this data is rendered is under our Insights tab. This is another area which you might be familiar with, especially for those of you who tuned into last month's webinar. This is where we host our ATS PMs, or our signal performance measures. You can see all the tiles here. It's also where our safety analytics live, so our pedestrian compliance and our red light runner charts. But for today's session, we're going to be clicking into the turning movement count view. And I have it preloaded here. Hopefully Technology continues to work and the internet connection is strong. Excellent, we're good. So the way that this data is generated or reported on is in our data link platform, and you can see it here. This particular intersection that we were at, this is data from yesterday. We counted around 14,000 vehicles, close to 2,000 pedestrians, and around 380 cyclists. What I do want to call out here is once you have this permanently installed at your intersections, you never have to pay for a traffic study ever again. You have access to all of our advanced study types. And in the context of today's world, especially in a COVID-19 world, the power really lies in the access that you have to historical data. So this is a snapshot of volume data from yesterday. The interesting thing to call out here is, unlike we would see in a pre-COVID world, there's no peaks to this data. Normally you see a clear AM peak, normally you see a clear PM peak, sometimes a little blip during lunchtime, but in this world, we're not seeing a lot of peaks. Now with historical data, because we're hosting this securely in the cloud through Amazon Web Services, we can go back a couple of months and look at the data, say on February the 27th, and get insight into what volume data looked like in a pre-COVID era. Now there's a whole host of use cases for this. A lot of agencies are trying to go through their cadence of signal retiming today. And of course, volume data on the streets right now isn't indicative of normal traffic volumes. That can be a little bit of a challenge, whereas if you had historical data, you could potentially use them as a surrogate measure for count season this time around. You could also look to this data as, how are urban policy or political decisions being followed? In the case of something like physical distancing, we can use this to see how much of a drop have we seen in our traffic volume and use that as an indicator into physical distancing policies. Another way that we can look at this is we have historical data on what normal traffic volumes look like. We know what the traffic volumes are like in today's world. Economic activity is a really important factor in today's world, but with COVID-19, how can we see how traffic volumes are changing and potentially use that as a surrogate indicator for how economic life is coming back into our city? So the applications and the use cases are very wide spanning, whether you want to go with your TIAs or your traffic signal retiming studies to some more niche as well as on the fly requests that may be coming out of your mayor's office or through the political sphere.
And to expand on some of the topics about being able to use data, continuous data that Sal was mentioning. This team was presented recently with a unique opportunity to work with one of our customers, the City of Detroit, to support their COVID-19 response efforts. So leveraging our existing traffic link deployments in the city, we were able to quickly create some prototype tools in order to help Detroit or assist Detroit in managing and measuring their response efforts. So I thought I'd take you through a couple of these tools right now because these tools really showcase the power of our detection and continuous counts app and the data that they can provide each of you. So before I do though, I do want to stress that these are prototypes as an extension of our Miovision Labs arm. Or division within our organization. But if you are interested in what I showed today, please do reach out to us at the end of the webinar or your sales rep. So the three tools that I'm going to highlight today are up on the screen. First is the testing site management. This is a report that uses real-time alerts, continuous counts, and video detection to help manage the flow at the mobile centers that have been set up. The second is the testing site real-time dashboard. So once the data has been collected at the mobile testing sites, these reports are shared with city and public officials to provide a real-time view of what's happening at the testing sites. And then based off of that data, the officials can respond accordingly. And the third one I'm going to go through is the citizen mobility report. This is a report. With this report, Detroit was able to measure how well citizens were following social distancing and the stay-at-home orders. And now that the stay-at-home orders have been lifted, it's giving them a view of what returning to normal looks like. So let's go a little bit deeper into each one of these reports, and I can show you how we were able to leverage our existing traffic link deployments to access this data. So first, here's the testing site management report. And what you're looking at is our traffic link deployment at one of their mobile testing sites. In the top left-hand corner, thanks Sal, you can see the lanes that were set up using the turning movement count views or counts that Sal was just demoing you. By doing this, we can count the number of cars entering the site to get tested. In the bottom left corner, we're reporting on presence data. This would typically be a stop bar at the intersection, but in this scenario, we're monitoring how long people are waiting to get tested. And then the images in the top middle and right are monitoring queue lengths. So we've set up several detection zones to determine the number of cars waiting in line to get tested. And then the bottom middle frame shows the rejection area, another detection zone created to count those that came into the testing site but didn't meet the minimum requirements, like having a doctor's note. So now that we have all this data, how do we share it? So flip to the next slide. This gives you a view into, again, another prototype report that we created, the testing site real-time dashboard. It was created so that the city officials and public health teams could have a real-time view into how well the testing sites were operating. By exporting the counting and presence data to the dashboards, you can see here we're able to show the city how many vehicles have been processed during a specific time frame. So whether it was 15 minutes, the past hour, or for today, the total testing time per vehicle, the queue times and wait times, and then the queue check at the bottom indicates whether we're in okay status or if those queues are backed up. With this data, public health and health officials could respond accordingly to what's happening at the testing site. And for example, if the queue length was backed up, they could send additional medical personnel out to help with demand. And then the third one is our citizen mobility report. Again, leveraging detection and continuous counts apps that we've been talking about today, we're able to collect the mobility data on pedestrians, vehicles, cyclists, cars, and trucks moving throughout the city. So by looking at this report and comparing it to historical data, the city was able to measure how well citizens were following those social distancing rules, as well as the stay-at-home orders during the early days of the pandemic. And they were able to see when and where there were still high volumes of traffic, whether or not vehicle volumes had decreased while other modes of transportation have increased. You'll see that here with the spike in truck traffic. It's interesting because this particular corridor is heavily used typically by cars, not trucks. So by taking a look at this data, you can assume that there's less cars on the road. So during COVID-19, the trucks were changing their traffic patterns. And then also by the orange line, you could see the spike in cyclists. Now this could be because of COVID, or this is also, March timeframe when the weather's getting a little bit nicer out and snow's melting. So they could have an increase of cyclists because of seasonality. So as the city starts to come back to life, the data within the report will also serve as a way to monitor the lift in economic activity, like Sal was mentioning earlier. Again, pulling on historical data, we can compare the data from today to that of early January or last year to see how things are returning to normal. Again, all of these reports have been developed through our innovation arm, Miovision Labs, and our prototypes. But if you are interested in learning more, please do reach out to us. And so with that, we've actually come to the end of what we wanted to share with you today, a little bit about us, our history, traffic link, and of course, the importance of continuous counts and how it can help you make accurate, reliable, data-driven decisions to help improve the mobility and safety of your cities. We do have some time, obviously, for questions. We always like to leave some time. So we're going to take a peek at them. But while we do that, I just wanted to point out in the toolbar, there's a section called Handouts. And we've included our continuous counts overview page in the handout pane, as well as our white paper on our traffic link accuracy white paper for you guys to take a peek at, which you will find valuable information is very closely tied to our continuous counts application.
Hey Shannon, I've got a few questions. Can I go ahead with them?
Oh, you for sure can. You got it.
So thanks everyone for participating. We've got some great questions coming into the queue here. The first is around how high does the SmartView 360 need to be positioned? We recommend about 30 feet high. We have seen instances where the higher the camera is, the better the configuration. But generally speaking, we recommend a 30-foot height on the camera deployment. Another question that we have is, sorry, the window's really tiny here. Some pricing questions on Scout, some pricing questions on Traffic Link. So for those, we'd recommend you connecting with our sales reps. They'd be best positioned to talk to you about pricing. Another question on accuracy, what's the error rate? Yep, so this is a common one that we tend to get when it comes to our continuous counts product. As many of you know, with the Scout line of business, we guarantee a 95% accuracy rate. And that's because our QA team will randomly sample bins and verify the data. So we're able to provide that guarantee. On the ITS line of business or with our traffic link solution, we don't have that QA team looking at the data. And so we don't have a hardened number to say, yep, we're 95% accurate here. My product management team and my technical product management team likes to get into the data science of it all. I'm not going to give you that response, but what I can tell you is we are highly accurate. Like I had mentioned, we've been in this business for well over 12 years now. And the most rigorous test that we've had is with the city of Toronto. You all remember the slide that we put up on the screen. We've been working really closely with the city of Toronto for the better part of a year now to hit their target requirements. And I can confidently say we have hit and exceeded their expectations for counts and accuracy for vehicles, pedestrians, as well as cyclists. If you do want to learn more about, say, the science and the rigor behind how we calculate accuracy, Shannon alluded to it, but I'd point you in the direction of the accuracy white paper. It's in the handout section of the GoToWebinar panel. That should answer any and all of your questions. We've got another question here. Is the video detection camera capable of capturing and storing data as being shown on the webinar, or is it being used for detection? So that's a great question. The camera is used for both applications. So I'm gonna go back in this slide deck a little bit just so I can speak to it. Oh wow, there must be a test. There we go. So to answer the question on the camera, there it is. The hardware is, think of it like a unified platform. Once you have all of this hardware deployed at the intersection, this is all you need to unlock a whole bunch of software value that Traffic Link has to offer. Now, part of that software value includes video detection, which the SmartView 360 is supporting with the Miovision Smart Sense. But another software module that we offer is our continuous counts product, which again, it's just leveraging the Smart Sense as well as the SmartView 360. So to answer your question, the camera is being used for multiple use cases. It actually also ties into our safety analytics product over here. We've got a few more questions that I'm just going to catch up on. So one question is speaking to our APIs. Yes, we do have data APIs that you can pull the data from the Traffic Link platform and Data Link to pull your volume trends into another dashboard or a custom tool that you have. Long answer to that question is yes, we have APIs that will allow you to pull the volume data that you want to render in some type of another platform or inject it somewhere else. Can you elaborate on the safety? These are some really great questions, so thanks everyone for participating. Can you elaborate on the safety analytics metrics and work that you can conduct? So whoever asked this question, I'd encourage you to refer to the webinar that we hosted last month. But to give you a high-level overview, we have two major safety analytics that we provide through TrafficLink. Continuous counts is part of that product where a lot of people find volume data important in safety analysis. But the two that we offer today are metrics on red light runners as well as pedestrian compliance. Red light runners are pretty self-explanatory. It's a metric that many in the industry are aware of. Pedestrian compliance is a metric that's special to Miovision, that's unique to us. No one else in the industry can offer it. And it's because of our unique functionality of being able to count and classify pedestrians. You can think of the pedestrian compliance metric as a red light runner report for our pedestrians. So it's visualizing both the frequency and severity of when pedestrians are crossing against the phase. But if you want to learn more about those, feel free to listen to the recorded webinar that we had last month on safety analytics. And with that, I think we're going to wrap it up. I know we've got a bunch of questions. For those of you whose questions we couldn't get to, stay tuned. What we'll do is, I think Shannon, keep me honest here, but we'll get someone from the team to reach out and answer your questions, because we do appreciate you taking the time to provide us with some thought-provoking questions. So we will make it a point to respond to those of you who didn't get a response. And Shannon, maybe you want to wrap things up from here.
Yep. Thank you, Sal, for joining me today, and thank you for all of you for joining. We know you have busy schedules, so we appreciate you taking 45 to 60 minutes out of your day to join us. Yeah, and to Sal's point, we will get to everybody that asked a question. We'll get your sales rep or technical account manager to reach out. In the meantime, if you are interested in learning more, you can reach out to either myself or Sal. Our contact information is up on the screen, or of course you can reach out to your sales rep if you know who that individual is. Again, thank you for your time today. Hope you're all keeping safe, and we'll let you go. Thanks for joining us.